This Zoom session is being brought to you by the fractal Picard Bust Peace Anchor. Okay. All right. So we're doing 9.6 and 9.7. 9.6 is about the laws of logarithms. 9.7 will solve exponential and logarithmic equations. Okay, logarithmic laws. Remember, b logarithm is what b must be raised to get x. B to the log base b of x is x. And conversely, log base b of b to the x is x. So it basically, logarithm looks at the exponent of the base for b. The logarithm and exponential base b are inverses of each other. It follows from this, for example, log base b of b is 1, because this is log base b of b to the first, so you get a 1. And log base b of 1, well, 1 is b to the 0, so log base b of 1 is 0. Now, okay, we can prove basically from the corresponding exponential laws that, well, exponentials turn sums into products. Logarithms turns products into sums. Exponentials turns differences into quotients. Logarithms turns quotients into differences. So log base b of x times y is log base b of x plus log base b of y. And log base b of x divided by y is log base b of x minus log base b of y. Now, here's log base b of x to a power p. Now, raising something to a power p is basically repeated multiplication times x p times. And so since logarithms turns multiplication into addition, it turns repeated multiplication into repeated addition, or in other words, multiplication. Log base b of x to the p is p log base b of x. Just a second. Now, I won't derive this from you. You can see it in the book. There's what they call the change of base formula. You derive it from this. And basically, it says your calculator may have logarithm base 10 and logarithm base e, common log or natural log. But you might want log base b of x. Well, it turns out to equal a ratio of common logs, common log x over common log b. It also equals a ratio of natural logs, natural log x over natural log b. Or really, it's a ratio of logs to any other base a, log base a of x over log base a of b. Now there's something called the pH scale. It measures the acidity, sourness, and bitterness of a solution. Sour is acidic, bitter is basic. pH is minus the common log of concentration of hydrogen ion in a solution. Well, asterisk, that's not really hydrogen ion. An ion of hydrogen would just be a bare proton, a subatomic particle. What usually happens in water is that it attaches itself to a water molecule, and so you get an ion H3O+. So really, that's what this is a concentration of H3O+. So minus the common log. So lower pH, because of the minus means that it's higher level of hydronium ion, and that makes it acidic and sour. Larger value of pH means a lower value of the ion concentration, and therefore basic or bitter. So examples. Let's simplify some logarithmic expression. Here's common log of 7c over 2. Well, this is log of a quotient, so it's minus log 7c minus log 2. There we have log of a product, and that's a log of a sum of logarithms. So log 7 plus log c minus log 2. Here's common log of x to the third, y to the second. We right away break that into log x third plus log y to the second. Then we bring the powers outside, 3 here, 2 here, and get 3 common log x plus 2 common log y. And here we have something a little more complicated. Common log base a, log base a of root 3 of x over root 4 of yz. Okay, first, logarithm of a quotient is a difference, so log base a of cube root of x minus log base a of 4th root of yz. Now, a cube root is a 1/3 power, and a 4th root is a 1/4 power. So we rewrite it as this: log base a of x to the third minus log base a of yz to the 4th. Now we bring out the 1/3 and the 1/4. the powers become multiples of the logarithm. 1/3 log base a of x minus 1/4 log base a of yz. Now here comes something a little bit tricky. Here we have a logarithm of a product, so this will be a sum of logarithms. So 1/3 log base a of x minus 1/4 log base a of y plus log base a of z. The tricky part is you have to put these inside parentheses. If you just wrote it without parentheses, well, you'd be wrong. You'd just be minus 1/4 log base of x plus, and then this separate thing log base is a of z, as if you put it in the numerator up here. So no, it's a minus 1/4 of the sum here inside parentheses. Then we distribute minus 1/4 over the parentheses. We get 1/3 log base a of x from here, and this distributed over these becomes minus 1/4 log base a of y minus 1/4 log base a of z. And that's the answer. You have log base 5 of 1 over t cubed to the d. What is that? All right, first the d comes outside, so it's d common log 5 of t of 1 over t cubed. 1 over t cubed is also t to the negative third. So this is d common log base 5 of t to the negative third. Then we bring the negative 3 outside, times the d, get minus 3d log base 5 of t is the answer here. Now here we're going to write it backwards, going to this collection, this combination, we'll write it as a single logarithm. Minus 3 log base b of x minus 2 log base b of y plus a half log base b of z. Okay, first thing, we move the minus 3 into the, as a power here. This minus 2 is a power here. This 1/2 is a power here. Log base b of x to the negative third plus log base b of y to the negative 2 plus log base b of z to the 1/2. Now here we have a sum of logarithms. That's a logarithm of a product. Log base b of x to the negative third, y to the negative 2, z to the 1/2. Then if you write a z to the 1/2 as a square root of z, and a negative third power as x to the third in the denominator, gesundheit. And y to the minus 2 power is y to the squared in the denominator. You get log base b of square root of z over x cubed y squared. And there's the answer. This was one logarithm. Castagneto. Just a second. All right. Here they ask to estimate to 4 places log base 3 of 7. Well, like I said, in your calculator, you'll probably just have common log or log or natural log, but that's all right. This will do. Log base 3 of 7 is log 7 over log 3. And you can calculate that, and the ratio is about 1.7712. Or here, log base 3 of 8, what's that? Well, it's common log 8 over common log 3. That over that, after a bit, it's 1.8928 to 4 places. This one, looks too much like 114. It's really 11 to the 4th power. You have log base 2 of 11 to the 4th, 4 log base 2 of 11, and log base 2 of 11, all that to the 4th power, which are equal, a and b. The 4 comes outside as a multiple. So these are equal. And this is an entirely different thing here. I mean, here, what happens here is we take 11, take its 4th power, and then the logarithm. Here we take 11, take its logarithm, and then the 4th power. Not the same thing. Here's what is the pH of a solution with hydrogen ion concentration, or to be precise, hydronium ion concentration of 1.7 times 10 to the negative 5th. All right, the pH is minus log, common log, of 1.7 times 10 to the negative 5th. With the calculator, turn out comes about 4.77. Fairly acidic. 7 is neutral.